Good evening, everybody, and welcome to you wherever you are in the world. I'm Stephen Taylor from Iverson College, something you perhaps never heard of. It's an event, a programmers retreat, which happened most years since 2011 of array programmers, people working with the Iversonian notation. We're here tonight to celebrate the life and work of Ken Iverson, and consider the prospects of what was once known as Iverson Notation. I'd like to say a big thank you to the British APL Association for hosting us on the video call, and to our panelists who have joined us at relatively short notice to contribute their thoughts, views, opinions, and experience. I'm going to turn first to a long-time collaborator with Ken Iverson, Roger Huey, who was the chief implementer of the J programming language, working very closely with Ken up at Kiln Farm a lot of the time, I believe. Roger, please tell us about that.
Thank you, Stephen, and thank you, British APL Association, for organizing and hosting this. I'm Roger Hui. I had the singular good fortune to apprentice with Ken Iverson between 1989 and 2004, working on J. Ken and I worked in our homes in Toronto. I in my apartment in the Hyde Park area, and Ken in his apartment on Erskine Avenue and subsequently in the Manulife Center. The arrangement placed me uniquely under Ken's influence. Let me share my screen. Oftentimes I find myself at Ken's house delivering the latest J version or working on a computer. And many times Ken would invite me to stay for lunch or dinner, explaining that thou shalt not muzzle the ox when he treadeth out the corn. It is said that if you keep playing chess with a grandmaster, your skills cannot help but improve. I had been in almost daily contact with the master between 1986 and 2004, and following are a few of the things I have learned. Farmer. Ken grew up on a farm near Camrose, Alberta, and only left to enlist in the armed forces in World War II. I believe that being a farmer left a lifelong imprint, expressing directly, favoring practicality, broking no nonsense. Credit. When Ken was at Harvard, a fellow student habitually stamped his papers copyright or confidential. Howard Aiken, head of the Comm Lab and Ken's thesis supervisor, advised, "Don't worry about people stealing your ideas. If it's any good, you'll have to ram it down their throats." Blame. Ken and I sometimes kidded each other about whose fault it was when something went wrong. He complained in jest that I, as implementer, had the attitude of, "Just tell me where to pour the concrete." And I, in turn, complained in jest that he, as designer, had the attitude that he was never to blame. If it's a mistake in the implementation, then it's obviously my fault. And if it's a mistake in the design, well, then I should have caught it during the implementation. Secret to success. In January 1992, I was in the final struggles of writing my book and implementation of J, having difficulty and under time pressure. Around that time, Ken was polishing off several books and papers, seemingly effortlessly. I asked him what his secret was. His reply was basically, first write 500 papers. Reading and writing carefully. In the early days, I did not have direct access to Ken and therefore read his papers carefully. Another example is Arthur Whitney's one-page thing, which was the final thing I studied for 1 week before writing the first line of source code for J. Over the years, I have benefited enormously from such careful reading. I later realized that Ken wrote carefully in the expectation that what he wrote would be read carefully. It annoyed Ken to no end when accused of being too terse. For example, as in, the J dictionary is too terse, when terse means effectively concise. Words. Ken was deeply interested in words, in their use and their etymology. He indeed did read the dictionary and kept a copy of the American Heritage Dictionary, along with other dictionaries, by his easy chair for ready reference. He has especially encouraged me to consult its section on Indo-European roots in the back of the AHD, which makes deep and uncommon connections between words. Many of Ken's relatives and friends received from him the AHD as a present. I myself did not, because I had already owned one years before I met Ken. In fact, I gave him the third edition of the AHD as a present. I think nothing I had ever done impressed Ken quite as much as when I found the word rametic, meaning pertaining to the formation of words, a word he had been searching for some time. Thus, the phrase rametic rules of J made its way into the J dictionary. Politics. Unsurprisingly, Ken stood up for what he believed in. He once spent a few hours in jail after being arrested during the protest against the Vietnam War. In the same cell was Gary Wills, the historian and author. Respect for people. Ken liked to tell the story of the Stoic service agent. At an airport counter, an irate traveler was berating the service agent over something or other, which the agent took with stoic forbearance. After the traveler went on his way, the next person in line told the agent, "I'm amazed at how well you took that abuse." The agent smiled thinly and replied, "Oh, the gentleman is flying to Chicago, but his luggage is going to Moscow." A questioning and flexible mind. The flexibility of mind that Ken brought to his work was also demonstrated in his daily life. For example, it astounded me how often and how thoroughly Ken rearranged the furniture in his home. His explanation was, our needs have changed, and we rearranged our surroundings to meet those needs. For more on the life and works of Ken Iverson, see the articles and papers listed on the right here. Thank you very much.
It gives me great pleasure to introduce Leslie Goldsmith, my former colleague at IP Sharp Associates and my present colleague at KX Systems. I doubt that Leslie was planning to tell you this story, but as I understood it, after a little hacking adventure during high school, he was served community service by joining the IP Sharp Systems software team as its youngest member. And wrote the first email system that I ever used. Leslie.
Thank you, Stephen, I think. Let me share my screen here. Everyone see that okay? It's a rhetorical question. Okay. I first met Ken when I was in my teens. And although I had learned APL several years earlier, of course, Ken's name and his reputation were certainly well known to me. What struck me immediately about Ken was that his larger-than-life stature hid the mild-mannered personality that those who had the privilege to work with him came to admire and respect so much. and that respect was often mutual. Ken had time for anyone who could engage him in good conversation or debate. He was a formidable opponent in discussions about language evolution, and two of his favorite languages were APL and English. On a pedestal in his office, Ken proudly displayed his copy of the Compact OED, a 2-volume etymological dictionary with print that was so condensed it came with its own magnifying glass. From this tome, he divined inspiration for what to call new functions he was contemplating adding to his other favorite language. To Ken, the name was as important as the formal definition. At the time, I worked for the systems group at IP Sharp Associates, informally called the Zoo. The Zoo's mandate was the design and implementation of the APL language, its environment, and the supporting systems necessary to run a commercial offering. We were all thrilled when we learned in 1979 that Ken would be moving on from IBM to join the Zoo. It was just months after he had won the ACM's prestigious Turing Award for his pioneering work on the APL language, interactive systems, educational uses of APL, and programming language theory and practice. I have many fond memories of conversations and debates with Ken in our years at IP Sharp, but there's one in particular I'd like to recount. This is actually a meta story. It was the morning of my thesis oral, and I decided to go to work that day to try to get my mind onto other things. As I walked to my office, I could see Ken at his desk down the hall, and I wandered over to talk to him. Sensing something was a little amiss, and maybe it was that I was wearing a tie that day, he asked me what was going on. Well, I knew that a Harvard professor would certainly be able to relate to a student who was nervous about an oral. So we chatted, and I told him that what I'd really like to do was to move the clock forward about 3 hours. He thought for a moment and asked, "Do you know your stuff?" "I think so," I said. "What you need to be is confident and cautious," Ken said. "You've just spent 2 years researching this topic, and you'll probably know more about it than anyone else in the room. But let me tell you a story," he continued. "I remember one Harvard dissertation where the student was cocky. All of us on the dissertation committee picked up on it pretty quickly, and the attitude just kept getting worse. At one point, one of my colleagues had had enough. He interrupted the student and said, 'When you say on page 76 that such and such follows, prove it.' The student responded, 'Well, I need the formula for so-and-so to do that.' Professor, 'What is that formula?' Student, 'When I need to know it, I can look it up.' Mimicking the professor, Ken leaned forward toward me and said, 'You need to know it now.' I asked Ken what happened next. 'He failed the oral,' was the response. In retrospect, I'm really not sure why these words didn't terrify me even more, but coming from Ken, they were somehow very calming at the time. The first thing I did when I finished at the university was return to the office to thank him. Ken was a big proponent of notation as a tool of thought, that the very way you were free to express a concept can have a profound impact on your thinking about how to approach it, and that precision of notation permits a rigorous algorithmic treatment of a topic. Borrowing an analogy from Ayn Rand, computer languages can broadly be classified into 3 groups: an old abstraction viewed through an old lens, and this is most procedural languages out there; an old abstraction viewed through a new lens, for example, special purpose languages such as Lisp, Snowball, or even SQL; and a new abstraction viewed through a new lens. In this last regard, APL and the progeny it influenced stand alone. I'd like to point to 2 thoughts from Ken's 1979 Turing Award lecture entitled "Notation as a Tool of Thought." He wrote, "If it is to be effective as a tool of thought, a notation must allow convenient expression not only of notions arising directly from a problem, but also of those arising in subsequent analysis, generalization, and specialization." To punctuate this statement, Ken used the example of a multi-layer crystalline structure whose planar atomic counts can be calculated trivially using a simple reduction and scan. The second thought is this: the utility of a language as a tool of thought increases with the range of topics it can treat, but decreases with the amount of vocabulary and the complexity of grammatical rules which the user must keep in mind. Economy of notation is therefore important. To illustrate this thought, Ken gave as an example the divalent nature of many APL functions and how functions can be extended to different data types in a consistent and logical fashion, often taking advantage of the fact that Booleans are a subset of integers, which are a subset of reals, and any operation applying to a set clearly applies to a subset. Both of these principles serve to increase the economy of a small number of functions without sacrificing uniformity, in fact, often while emphasizing it. What I think is especially interesting about these two statements is that, although made years ago in the context of programming language design, they are equally apropos today for enterprise application design. The key to good design remains minimalism, which we might define as the careful choice of elementary concepts upon which functional requirements not even imagined can later be supported in an innate manner. Good design is about making the hard decisions regarding what not to include. Looking ahead, we're living in interesting times with respect to computing in general and array languages such as APL, J, K, and Q in particular. Mastering these languages takes a particular mindset, intellect even, and not all developers see the need to broaden their horizons beyond the more mainstream von Neumann family of languages. But several things have changed over the past years. First, it used to be a challenge to convince someone of the power and utility of interpreted languages over compiled. That discussion no longer comes up, thanks in part to advances made in other languages that either blur the distinction or render the point moot. Second, systems used to be built using a single programming language. Although you might not have known or even cared what the implementation language of a particular product was, the odds were good there was only one language behind it. Now, thanks to layered architectures, language specialties, and open source, heterogeneous solutions are ubiquitous and even expected. Third, the amount of generated data is going up by more than a tad each year, and along with it, the overall complexity of the software that we're expected to write. This suggests that our efficiency at solving problems is only going to become increasingly important over time. As Henry Petrosky pointed out, the most amazing achievement of the computer software industry is its continuing cancellation of the steady and staggering gains made by the computer hardware industry. Contrary to what people might have thought decades ago, we haven't, and I don't think ever will, achieved a place of permanent homeostasis when it comes to software function and performance. That's good news for job security, and it's good news for languages that emphasize performance or expressiveness. Because the one thing that is certain is that good software developers using good tools will have a role to play for a very long time to come. I love this comment about our industry from Bill Bryson. Just as with object-oriented programming and their languages, the language itself doesn't guarantee the quality of the results, but it sure helps. So I'm optimistic about the future of languages that are Ken's legacy. The cognitive opportunities of these languages are both alluring and addictive. Array languages seem at once so inevitable and natural that it's easy to forget that they were really designed, and designed so well that they completely shield users from the complexity of what makes them so powerful. And in this regard, especially, we all owe a debt of gratitude to Ken. Stephen?
Leslie, thank you. A lot to chew on there. And I've got a comment from Chris in New York. Leslie mentioned the word tome in reference to the compact Oxford English Dictionary. Ken once called me on a similar usage. I forget the specific example. Ken pointed out that the tome comes from the Latin tomus, meaning section, and not the whole big thing. Yeah, I remember.
There is a legitimate dictionary definition of it, which is akin to an opus, but doesn't necessarily imply it's a single work. So I don't know. I'm not sure about that. It's worth looking up further, I guess. Apologies if I misused it.
It's a good tradition. I'm going to ask the other members of the panel to introduce themselves and say something briefly about your relationship to Iverson Notation in any of its various forms. And I'll start with Nick Saris.
Hi, hello. Yes, I'm Nick Pasaris. I was introduced to Q in 2006. I had moved to Hong Kong, and all by myself, I had to read Arthur Whitney's abridged version of the KDB and the Q manual that was online. And over the past 14 years or so, I've continued to immerse myself in the language, learn about the different sorry, I'm taking too long, but I've learned to appreciate the ways of overloading functions based on their type to minimize the number of functions that are needed to memorize. And in that process, felt that my education would be shared with other people, and I've written 2 books on the topic.
Nick, thank you. Aaron, Could you introduce yourself, please?
Me, right?
Mm.
Yeah, okay. So I'm Aaron Su. I am the creator of the Codefense compiler, and I first encountered APL in my graduate studies, initially as a tool of fear that we use to scare people into learning Scheme during the undergraduate courses. But later on, I became quite a big fan of APL because it was the one language whose essence I completely failed to steal and incorporate into my Scheme programming habits. And in so doing, it essentially converted me to an array programmer.
Thank you. Dave Thomas.
I think I'm the fossil here. Basically, I've been traveling in multiple languages for some time. I started APL when there was one Selectric keyboard in the university, and so I had to learn how to program an APL, Xerox APL, using dollar transpose, or the shorter acronym was Xerox APL, and in spite of that, managed to continue. I've traveled in and out with APL and J and K communities, and it's been a privilege to be involved.
Thank you. Rebecca.
Oh, that's not a tough lineup to follow or anything. I'm Rebecca. I'm the technical evangelist, well, one of the technical evangelists with KX. I'm probably one of the people on the panel that has less years in the game, so to speak, when it comes to the languages of choice. Been, I suppose, developing using KDB for many years now, and I still enjoy it. Even just more recently, the advent of code. I can't say I'm going to win any prizes for my code, but there's something very beautiful about it that I think a lot of people here today kind of appreciate. So yeah, very happy to be here. Thanks, Stephen.
Thank you, Rebecca. Devin.
Hi, I'm Devin McCormick. I started with APL back when I was in junior high school, and I think to the point Aaron was making about the foundations of mathematics, I was learning about linear algebra and things like matrix multiplication, and it made a lot more sense when you could actually do it like that. And it seemed then that this sort of language was the wave of the future. That was a while ago. I won't say how long ago, but Great Sheets of Ice did cover much of the North American continent back then. And I'm still kind of waiting for the rest of the world to catch up, which it has slowly been doing. And perhaps if I live another 50 years, we'll even see that happen. Currently, I do a lot of my work with J, though I have recently been getting back into APL. And I run the New York City J Users Group, second Tuesday of the month for the past 15 years. So my little plug there. And I'm hoping to speed up this more widespread adoption of array languages so I can see them become a commonplace while I'm still around.
Thank you. Morton, I believe you've got some similar ambitions.
Yeah, well, I was given a free account on this IP Sharp time sharing system back in 1979 when IP Sharp set up an office in Oslo and rented a flat from my dad. And after I'd been doing APL, sort of after school, I was in high school at the time, they started paying me for my time. And I've been doing APL ever since. I'm a monoglot programmer. And the last 15 years, I've been flipping between the CTO and the CXO of Dialog Limited, who make APL interpreters for a living. So today I'm involved in design and implementation of APL, as I was working for IP Sharp back in the good old days. It's good to be back with an APL vendor.
Thank you. Lurking in the background, I think Simon Garland actually managed to join us from Switzerland. Are you there, Simon? Can you introduce yourself?
Yeah. Wait. Don't seem to be appearing.
I can see you.
See you.
Okay. So I'm Simon. A lot of the KX people know me. I have an interesting viewpoint on languages like APL, I think, because I was lucky that it was the first language that I learned, almost. Actually, I learned it. I thought I just had to learn something quickly to have a job for the winter until the sailing season started again. And then stuff took its own way, and I ended up programming with array languages. Almost all the time I was programming. And what was interesting with APL in the early days was that because it was typically on something like a time sharing machine, there was no question that if anything went wrong, it was your code and you had to look in there and fix it. You couldn't assume it was in the implementation because nothing would ever go wrong with the interpreter. And that carried on with other languages. We were always forced at a high level. So with APL, J, K, Q, it was an interesting different way of programming to have to stick at the high level. These days, people are much more ready to drop down to C or Java or other things. Whereas earlier, you had the language and that was all you had. And if you couldn't think of a way of expressing the problem in APL, you were stuck because there was nothing else. So you had to take your code, think about it a bit, then take it for a walk somewhere until you worked out a way of solving it. You couldn't drop to something different or a different paradigm or faster way of working. And I think that was a very interesting way of working and led to the sort of systems that maybe the older programmers write, being in lots of ways a lot simpler because you were forced to spend more time working out how on earth to do something, and you didn't have any cop-outs like dropping to other more appropriate languages. If the truth be told.
Dropping to more appropriate languages.
Well, I was being very polite there, as so many people. My opinion, I think most people know, but then one has to leave the door open, perhaps. Okay, Stephen, you can have it back again now.
Oh, thank you. I started out myself with scientific programming in Fortran. Somebody, when I was working for a time-sharing service, showed me APL, and I loved not having to write loops. I loved it that I was working in a language where iteration was basically free. It was kind of implicit in all the primitives. I subsequently went on and used lots of other languages, but I keep finding myself coming back to APL just for the pleasure of it. It's a question which is kind of nagged at the back of my mind for a long time. What is it about this? Why do I think that this notation in its various forms, I've seen it in APL, in J, and now using it in Q, what do I find special about it? And closest I've been able to say is a kind of poetry in akin to the pleasure and the satisfaction I get in mathematics and seeing something very concisely and perfectly said. And it's those of us who enjoy poetry get a similar experience when you get a phrase or an expression that just absolutely effing nails usually three thoughts at once, and carries them in a way that's kind of indestructible. So for me, there's a real buzz in being able to write code of that kind of clarity and power. Not every day, of course, but occasionally you get to do it, and it's a real buzz. There was a theory going around quite some time ago that the notation being derived from a mathematical notation for describing computer processes rather than being kind of an engineering solution for shoving bits around, that the notation kind of maps to your thought processes better. This is, of course, Ken Iverson's whole thesis with notation as a tool of thought, because you don't have to map it from your brain through to a language like English, especially English, so many programming languages kind of assume fluency in English, and then on to your executable notation, that APL in its original form as a symbolic language would function more directly, or cutting one layer out, and that in doing so, it would make programming more accessible to people who are not native English speakers. And I've got a couple of contributions I want to share with you from non-English speakers here, or people for whom English was not their first language. This is from Kyosuke Saigusa in Japan. Japanese in general had aspired to learn from advanced culture abroad, first China and since 1600 on from Europe. We have no resistance to use English terms in science, technology, and business. Japanese language uses many English terms in self-styled manner, but when it comes to speaking and listening, many of us have difficulty in communicating. I always believed APL, with its graphical symbols, simple syntax, expandability, and all other qualities, could be an ideal language for programming. Therefore, I pursued adapting this language in real world around me. I have written many living examples, but I had limitations one day when I learned that IBM APL2, which I had been using, has no recognition amongst language specialists in academic world, perhaps because APL2 is a minor product and not open to public more easily. I think that it requires generations after us when APL arrives. So a rather pessimistic view of the future for the notation. Here's some thoughts from Pierre Kovalev, who's a KD Plus implementer and was raised in Russia. I believe I learned Latin symbols at about the same time as reading and writing Cyrillic. I started with logo at age 6, barely able to read Russian, and had to learn writing on the go. Logo commands were abbreviated Russian, but the environment, DOS NetWare, wasn't translated, so we needed to know Latin to log in and run commands. Reading Russian abbreviations or English commands as natural language words never made much sense to me. They were always abstract symbols. When learning BASIC a couple of years later, it occurred to me that for is an actual English word. I marveled at the effort a native speaker would expend to avoid confusing a preposition with an unrelated programming concept. I still consider non-native or rather non-verbal symbols for programming an advantage. And as far as I know, many Russian programmers agree. If you want to avoid confusion with natural language, familiar graphical symbols are valuable as a memory aid. It seems APL largely succeeds here. I never had this problem with K, as the cultural context of ASCII makes mistaking, say, dot for comma impossible. I confess I didn't quite get the import of that last remark, but it does remind me of a remark of Arthur Whitney's once, where he said the shortest, most terse, most compact program is a dot, but it just depends in which language you interpret it. Lastly, on the subject of the Iverson notation and non-English languages, I was very pleased. And a few days ago, I got this contribution from Hong Kong. The gentleman who sent it to me, the KDB China workshop, they tell me that their English is not good enough to participate in tonight's events. They have to use Google Translate even to correspond with me by email, and yet they've been able to master KDB and write a textbook, which has just been produced. So I'm going to play their contribution now. I still remember how to share the screen.
everyone. I'm a member from the KDBCN workshop. Commemorating the centenary of Ken Iverson's birth is very meaningful. We pay tribute to Ken Iverson, Arthur Whitney, Roger Hui, the masters who invented APL and its descendant languages. We sincerely thank them for their great contributions. We completed the writing of KDB Plus tutorial in Chinese in 2020 and recently officially launched it at the website kdbcn.gitee.io. As far as we know, this book is the first Chinese introductory book about KDB Plus or Q in China. There are no Chinese books about the KDB Plus or Q yet. Therefore, some of our KDB Plus or Q enthusiasts organize and compile this Chinese tutorial, providing a quick start tutorial for readers who are interested in learning KDB Plus or Q. We believe that this book will provide a convenient and useful introductory course for data processing personnel, quantitative investors, quantitative platform developers, software engineers, statistics and machine learning professionals and students, and those who are interested in big data analysis. They can become familiar with the use of KDB Plus or Q as soon as possible. We hope to promote the ATL's descendant languages in China and hope that more people will benefit from it. On behalf of all authors of KDB Plus tutorial in Chinese, I wish the centenary of Ken Iverson's birth a complete success. Thank you.
When you see a language spread when you see a programming language spread out across multiple natural languages, that's always a sign of strength and something to encourage everybody who'd like to see Iverson notation used more widely.
No, to Chinese, the character set, APL character set, either 88 or 130 or whatever it is not an obstacle. I'm a mere 200 symbols. What's that?
Well, we've come a long way. I remember what somebody called the ASCII panic of the 90s, where before personal computers could handle Unicode conveniently, when APL seemed to kind of drop through the floors simply because you couldn't work with an ASCII keyboard. I can see I can see quite a bit of activity in the chat. I should have said, if you'd like to pose a question to the panelists, please use the Q&A panel. You should find that at the bottom. What's my place here? Yeah. We're here tonight, as I said at the beginning, to remember Ken Iverson and his work and discuss the future prospects of the various forms of his notation. This would be a good point if anyone recalls any stories about Ken. We've had a few already. Leslie, you look like you're ready to speak there.
No, I was just thinking. I'll give somebody else the chance.
Well, I had the privilege of being taught by him a long time ago on something he called his instructor's course for the working introduction to APL. And there I was taught what for me was a revolutionary principle. I imagine myself teaching people APL, how to do things, and he taught me not to do that. What he taught me was to get people to experiment and guide them while they explored, answer questions for themselves, to lead them to look stuff up in the reference, and generally become self-sufficient. I think one of the first things we did with students on the working introduction was to go to the reference and start putting sticky notes to bookmark things we needed. One of the very first things in the course was you typed in on the session 2*3, and when people found that it did not produce 6 as they expected, they needed to find out why. In APL, the star was the power function, so it produced 8 instead.
As somebody who has never actually had the privilege of meeting Ken, I figure now is my chance to come in with a nice parallel. Just on the back of your story there, Stephen, there's some quote from Albert Einstein where he says he doesn't ever try to teach people, he just tries to create the conditions necessary to learn. It sounds like perhaps Ken was also sort of following that kind of paradigm. Also, we do have a couple of raised hands in the attendee section, so maybe there's people there that would like to share a story.
Oh, thank you for spotting that. I see, yes. A panel I wasn't looking at. My goodness. We have, by the way, 191 people in this webinar, which is quite a spectacular result for such short notice. Jake, my co-host, can you assist me here? We got I'm unable to see the raised hands on my screen.
Yeah, I can't see them either, but I can see 3 are raised.
They're up at the top for me. They sort of escape the alphabetic and go all the way up.
There's a long list to go through. I see. Right, I'll start at the top. Bo Weber. Right, you're open to talk, Bo, if you'd like to unmute yourself.
Hi then. Did I have my hand up? I'll just say that I've worked on the APL-C, the APL to C compiler. I created a number of multitasking aspects, and multitasking is the core of my NMR software and pore size measuring software, which tends to run around 12 multitasking programs in parallel. So they just don't get in each other's way and just do things when the data is ready. All written in micro APL over since about 1980. Thank you.
Thanks, Bo. Jake, can we go to Rohan?
Yep, Rohan. Rohan, you're clear to speak.
Hello. Hello, everyone. Thank you. I just wanted to share a story. First year university, 1976, first year university algebra. The professor was saying, was talking about number systems, you know, like base 8, base 10, etc. And he said, and of course you can't have, and I forget, it was either a fractional base or a negative base. And a bunch of us jumped up and said, oh, yes, you can. And it turned out that those of us who had jumped up were the people who knew APL. And the professor said, wow, that's interesting. I'm going to have to dig out my old APL book. I was relating this story years later to a friend and who had gone to the same university, the University of Waterloo. And he said, oh, did you not know that that formed Professor Gilbert's research direction for the next 2 years? And I said, oh, no. And I looked at Professor Gilbert's website, and it was absolutely true.
Brian, thank you. Thank you. Can we go to Murray?
Yep.
Hi, I came to APL back around 1970 and used it for a number of years teaching. It was then the 8-plum system for APL that was developed at University of Massachusetts. But what I wanted to say for purposes of this conference is what a delight and challenge it was if you ever wanted to debate Ken. I learned from him in occasional informal groups of 2 or 3, but the one I remember most was a very public discussion at a meeting at a conference where I was comparing and contrasting my new love, Mathematica, with my old love, APL and J, and gave the count that, in fact, APL and J had many more separate functions than did Mathematica, and Ken got very upset by that, I remember. I don't think we ever resolved the difference. Now, if you counted today, he would be right, but it was not right then.
All right, thank you. Thank you for that.
We have another one here, Joey Tuttle.
Oh, Joey. Hello, Joey.
Hello, Stephen. I couldn't resist saying something. I first encountered APL in 1968, and it was a life changer. I haven't done other technical things much since then. So it's very good to see all familiar faces here, Roger and Simon and Morton. Yeah. So thank you for arranging this meeting and celebration. And I have lots of Ken stories, but people have told some of them here, and he was a lover of words. And I have several of his books, some of them signed, in my house, and they're very much appreciated. And I do appreciate hearing more, and I appreciate the youth here at that same conference that was just being described, where Mathematica and Stephen Wolfram was there. Stephen Wolfram made a remark. He said, "I think you should be concerned at how many people in this room have gray hair." And exactly. And so seeing young people is a wonderful thing. You 2 kids there, or 3 actually, I would count as kids. Anyway, thank you.
Joey, thank you. It's good to hear from you again. I'm going to ask Dave now to share us his thoughts on the future of the notation. Dave's got a wide experience of technical languages and is a frequent speaker at conferences on the futures of various technologies.
Thanks very much, Stephen. It's a privilege to be here. As I said, I've been allowed in and out of, probably allowed in and then thrown out of the APL, the J and Q and K communities several times. So it's great to be back with this group, and it's wonderful to have the opportunity to pay tribute to Ken. So let me just try and see if I can share my screen. Hopefully it's this one. You all see that?
Yep.
Thank you.
Looks good.
So my slides have a lot of text on them, mainly because I wanted to make sure that I think all of us are trying to share references. But I was asked to really talk about 2 things. One is the interaction of, the impact of APL in other languages, which is very significant. And also, since I'm old and grumpy, to talk a bit about the other side of the beautiful Iverson notation and perhaps what some of the challenges and opportunities are. So APL and Lisp kind of co-invented the read-eval print loop today, which is sort of the badge of honor. If you don't use a read-eval print loop today, then you're probably using one of those IDE things or something like that. But in practice, they're in both the IDE and in the text interface. And Alan Kay and Dan Ingalls, when they were working on Smalltalk just prior to the formation of the group at Xerox PARC, were really in love with APL, but they felt that it was just a language that's just too hard to gist, and the children wouldn't be able to get it. Obviously, they weren't talking to Ken, or he would have fixed that problem. But they were so inspired by APL that the Smalltalk Interactive Debugger and the IDE really influenced every other IDE, including the KX Analyst. Most recently, where basically the ideas in it came largely from APL and Smalltalk. So the whole notion of workspaces, variable inspection, breakpoints, be able to see all your functions, really is something that was invented and contributed by APL. Strangely enough, APL allowed me to understand Smalltalk. I was involved in Smalltalk very early, and Smalltalk, the language was really taken from Simula, which actually was inspired by another language called SimScript, and it was done in very secret at Xerox. There was Palo Alto Research Labs, and people only saw these screens with multiple windows on it and a mouse, but no one was really allowed to get near it for a long time. And finally, it was disclosed in 1981 in the Byte articles. And so with a grad student at the School of Business, where the only tool that was useful was APL, we built a semantic model for Smalltalk using something called the contour model. Contour model, interesting, was invented pretty close to around the time of APL. It was actually a visual model for describing the borough's hardware. So to try and figure out what was going on in Smalltalk, we built an APL implementation, and 2 years later, I was able to find out that we actually had the correct implementation. But without that APL model and interpreter, we wouldn't have been able to understand what object orientation was about. So it's an odd twist. Now some heretical thoughts on Iverson notation system. First of all, the notation that we know is amazing. It was so expressive that my business students were happy to use, $row, $TRP, because they didn't have real APL keyboards, and delightfully amazed their professors by doing all sorts of things with APL that professors thought took, teams of Fortran programmers. Unfortunately, some of the things about APL and array languages have been off-putting, and we all know what those are, or heard what they are. And tacit point-free, particularly in the functional programming now, is back, and tacit programming is definitely a badge of honor in our community and in the functional programming community. However, for many, it appears as the ultimate obfuscation. So sometimes what is concise and beautiful to some is not always to others. Now, J, K, Q, Niel addressed a lot of the problems by bringing in ASCII characters and keywords. However, they required overloading at some expense of readability. They also solved problems with function composition, non-array data types, and so on. But you wonder today, we have Unicode. We've had Unicode for a long time. We have fonts, we have colors, and yet we're still stuck looking at programs in ASCII. And it seems that, I personally would like not to have to overload ASCII characters, and I don't see why I can't have a real assignment arrow and all those other nice things. So I think we could do a lot by taking ourselves back to the symbol world and perhaps forward into the keyword world. Anyway, that's the thought. And the final set of thoughts is that basically European-inspired written languages usually are executed written left to right. There's a set of languages called concatenative language, such as Forth and PostScript, Factor, which are stack-based and execute left to right. Now, COSI is an example APL dialect that adopts this sort of style. POP2 put assignment at the end, which is consistent. If you're going to go from my point of view left to right, then the assignment should be on the right. It also adds precedence so that you can write infix things, which kind of overcomes a bunch of the problems you have with left to right languages, which are stack-based, because X, Y, plus gets pretty irritating if you start writing complicated expressions. Anyone who's tried doing Forth or an old HP calculator knows this. We really need support for polishing code to efficient, concise form, as well as teasing it apart to repair defects or functionality, right? It's good to be able to have tight code, but we have no tools today to do that other than text editor, and it's easy to make mistakes. Complex code created from multiple internal, external contributors as we build bigger systems creates problems, particularly name conflicts. We really need modern modular package managers to support the composition of larger applications. They're available in pip, which is okay. Rust Cargo is even better. I think we need to look at that. And finally, modern languages have type systems which allow you to identify bugs at compile time. This, means you don't get the finger of fate, backtick what, So I think something that we also look at, because type systems reduce testing and runtime errors. Other languages provide contracts or invariants which can be checked either compile time or runtime. And research in type systems hold lots of promises for Iverson-inspired languages. I put a couple of references at the bottom. And just recently, Gilad Braki, who you might know from Java Hotspot and other things, a language called Newspeak, is working on a new language, and he just published a talk at the recent ACM Rebase conference on an array language which tries to accommodate a type system. Now, it's not done yet, but I think there's some promising things there. So those are the sorts of things I think which would take and help array notation move further, and I appreciate the opportunity to share the time with you. Thanks.
Thank you, Dave. Don't cry for me, APL symbol set. Some of us never left you. Morton, at Dialog APL, you've been using the APL symbol set consistently and are completely happy with it. Let's hear your thoughts on this. And
share my screen. Do you see Ken Iverson?
Yes.
Okay, so thanks for the invitation to share my thoughts about the future of the notation. It's really good to be invited to an event like this and get your face off, get off the cold face where you've been either in enhancing the language or maybe dealing with bugs in it, and think about how everything you're doing fits into a bigger picture. So here's my Ken story. I guess really to attest to his politeness and willingness to engage anyone in conversation. When I was a 19-year-old Norwegian punk, Ken visited the home country to meet his family, and I had the opportunity to meet with him, and I launched into an attack on the circle functions, where we have these numeric left arguments, right? 1 circle is the sine, 2 circle is the cosine, 3 is the tangent. And I just learned APL, and I thought this was such a cop-out and a lack of imagination. He should have come up with another 10 symbols for these trigonometric functions. And he listened to me calmly and, asked me to come up with a better suggestion. And the last 15 years, I've been in a position where I could have asked the development team to try and come up with a better suggestion, but my imagination failed me. So he was right. Will the notation survive? Well, no points for guessing my thoughts on that. And it's not necessarily that, the organizations currently delivering array languages will survive forever, because there will be change. Maybe we need, the kind of advances, some of the ones that Dave was talking about. But I think a lot of us feel, the same way as Michelangelo's art and other things that have sort of been distilled down to crystalline perfection, that Iverson and his colleagues didn't really invent APL, they discovered it. So if it should disappear for a while, it's going to be rediscovered because it has really fundamental value in it. One of the things that sort of constantly plagues us when we're trying to discuss with people outside the APL community is this notion of notation versus programming language. How do we explain APL to computer scientists? And we have the name APL sort of doesn't really help us here. You have to remember that it was coined at a time where programming languages were sort of still being, the whole notion was being discovered. And when we suddenly look at our APL users, if we look back at the history, they all, the most successful ones didn't have programming as their primary skill. And they were really looking for something to help them. So this is a well-known algorithm used in teaching people algorithms, the Loon algorithm for computing the checksum. So the kind of people who were coming up with this, I don't think Loon had APL, but on Wikipedia there's this textual description from the rightmost digit moving left, double the value every second digit, blah 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 blah. And the real value of APL is if somebody like Loon, when he was inventing this, could have used a notation where he could, using an array language, refer to these digits. And the big advantage to me of this notation is that it's terse, and it suggests there's this notion of suggestivity, right? It suggests maybe you could use other weights if you have insight into the mathematics behind this. You could easily experiment with other checksum algorithms by making very small changes to this code. And that's where the real long-lasting value of APL is. At the moment, we're also benefiting from, I think Leslie talked a bit about this, how interpreted languages can be so efficient, because at the moment, if you write in a functional and array-oriented style, the way hardware is evolving, you actually get code that runs very, very efficiently on modern hardware. So that's something that users of Q and APL and J are also taking advantage of, the fact that you're working on very dense data structures with sequential access that the processors can really optimize. But that was sort of never part of the design. That's sort of a lucky thing that's fallen out of it. Now, of course, there are a lot of criticisms of APL, like the ones that Dave was mentioning. There's the weird symbols. There's the infix notation for all functions, so we can only have like an argument on the left and an argument on the right. There's the operators versus functions, at least in APL and J. So we don't have true first-class functions. We don't have type declarations, and it's all dynamic scope, global by default, etc., which makes programming in the large harder. It's harder to prove the correctness of things. But if I just click on with my mouse here and look at the next slide, the strength of APL, of course, I consider, and many users of APL consider these same things to be the advantage. It's the symbols that make the suggestivity and so on work. It's the wonderful relationship between operators and functions that make it possible for people who haven't studied computer science to write domain-specific languages in APL and really model stuff, and not having to do type declarations and so on is also very helpful. So it depends on what you're trying to do and where the real value is coming from. Now, of course, those of us who have to deliver APL systems that are used for programming in the large have added things like control structures and lexical scope and object-oriented programming and so on. But in modern APL, you will find lines of code that look like this. I don't really consider those to be part of the notation that maybe will survive. They are more necessary evil wrappers that we use to package the notation to deliver it to execution. So what do we need to do to ensure that the notation is still relevant on Iverson's 200th birthday? Is an interesting question. So in other words, when Python and JavaScript have been swept aside, and web platforms and APIs, GUI APIs, and the security madness is all behind us, that's been nicely packaged, and people can get back to the business of writing algorithms to solve problems again. Well, I would suggest it's not by making the language more like Python or JavaScript. It's focusing on that which really is unique and delivers value, lasting value. The part of the criticism of APL that Dave also mentioned that I really do agree with is a problem is on the ecosystem side rather than the language side. I believe the problems with typesetting, I think even Dave is saying, yeah, he would like to have an assignment arrow, and today it's really the keyboarding that's the problem now rather than the Unicode display in our experience. These things that are up on the screen now are real problems that we face in bringing a new generation of programmers to the language, because some people, when I interview them for jobs, I say, well, how do you pick a programming language? And they'll say, well, first I look at the libraries that are available, and then I'll pick a language basically based on what libraries you can find. And there are some things here that for historical reasons and because of technical limitations in the language are hard to do. And these are things that this is where we need to focus our efforts to make the language survive, or at least be used continuously for the next 100 years. The good news is that we have time to work on this, and there is a steady supply of people who want to learn how to solve problems on a computer. This is how biology works, fortunately. So here are some of the winners of the last few years worth of dialogue problem-solving contests. And these people, we asked them to write something about the experience of learning APL to participate. And they will say things like this. I'm not going to read it aloud. I'll just leave it there for a few seconds. But this is a kid who is familiar with C# and Python. And APL is definitely his favorite language. So I'm not saying everybody feels this way, but there's quite a significant bunch of people who do feel this way. So if we can get those ecosystem problems sorted out, I think we're doing well. And the thing we need to focus on is the poetry, as Stephen mentioned. So the fact that in APL, so here are some explicit versions. And I personally do agree with Dave that the tacit forms that we have at the bottom are perhaps taking APL a bit too far. I see the huge power and elegance, but I agree that it's maybe taking the abstraction a little bit too far. But the things at the top there, to me, are sort of fundamentally beautiful and poetic, and I don't know of any other type of language that come anywhere close to this. The one in the bottom left is a bit of a joke, by the way, written by, I think, Adam Brusewski. I think the left part of the expression is actually completely unnecessary. The palindrome is the right part and the rest is a no-op, but it's fun. And fun is a really important thing about APL. So here's an expression. So here's my circle function, and there's a bit of fun. If you want to draw with ASCII art, a circle with a radius of 5, you can write it like this. And here it's really nice that you can get the sine and the cosine with an outer product. And that's what makes this really works. And one of my favorite quotes, several of us from Dialogue have been going to a conference called Functional Conf in Bangalore for the last several years. Unfortunately, not this year. It, like everything else, is off. But after one of my talks there, I had a kid come up to me and say, with clearly he couldn't quite understand this. You've been using the same programming language for more than 30 years, and you're still smiling. And we need to hold on to that. And I don't see why we can't do that and solve the ecosystem problems. So that's my view of the future. Thank you.
Morten, thank you. I've got a direct question for you from Greg in the audience. Jake, can we go to Greg? I'll read the question out. To choosing language by libraries. In some sense, the APL interpreter was largely a delivery vehicle for a great linear algebra library, etc. How can the language continue to grow in such a role?
I think I would say it can't really, because linear, well, actually, it depends on what you're doing. I mean, if you're trying to solve huge systems of linear equations, APL has this serial problem that it's used to prototype new technology, and then that technology becomes commoditized or specialized. People go off and do things like Mathematica or MATLAB or something. Having learned APL, perhaps originally, they get an idea for something which is more of a workbench, delivers certain types of results much faster, and then they go off and commercialize that. And that business gets taken away from APL. Spreadsheets, CRM systems, pretty much any kind of system was prototyped, or many of them were prototyped in APL, and then the business went away. Sometimes people see that as sort of like APL losing out, but in fact, that's not how I see it. APL is being used to discover new stuff, which then business people go off and it's maybe a bit unfair. I see Q as something a bit like that, a sort of a database specialized time series APL system for very high performance time series analysis.
But I'd see the same thing happening even with Q, where almost all the new tools are prototyped in Q, and then people grab it and they pull it over and they rewrite it in another language. And perhaps the typical complaint is that there's not enough developers, the developers cost too much, things like that. So
it's a bit like the you've got the special armed forces, the guys with the scuba gear who parachute off helicopters at night, and then when they've secured the beachhead, you bring in the infantry, and the infantry uses a completely different set of tools. And but I don't think this is something we necessarily need to be very unhappy about. It can be a very good life, even if you're not in the infantry.
Morten, thank you. I certainly feel I've had a very good working life courtesy of Ken Iverson's work. I'd like to cut here to Devin, who I think in recent years has worked primarily with Jay, Ken's reboot of APL, starting about 1990.
Yeah, a lot of what I do with the New York J users group is we always have sort of a fixed set of topics, and the first one is what we call beginner's regatta. It's an ongoing attempt to address very basic questions and introduce people to how to do simple things. And you see this a lot in the forums. You'll get a lot of the same questions over and over on the forums, and sometimes they're sort of mistaken questions. They want to do this thing that they did in their C program, which involves getting two numbers from a user and adding them together. And it's really difficult to do the bit where you put up the prompt, give me a number, and then take the number, and then give me another number. That part is sort of difficult because you don't do that in APL and J. You're already working in an interpreted environment, so you don't do this. You don't build in the interaction like you do, like you're forced to do in other languages. It's already there. So it's a kind of a funny question that keeps recurring, that people want to do this thing without realizing that they don't have to do that. And that I see it's just coming from other languages. There's a lot of mistaken notions that are built into how people approach things. And in fact, just recently when I announced this this conference on Reddit, someone replies, and I threw in something, a little bit of, why would you want to use a notation? And so I said, well, which one of these is simpler? 1 + 1 with symbols, or spelling out ONE PLUSONE. And I get a sort of a angry reply to that, which this person says, well, fortunately, this will stay a niche. In other words, you guys can continue to be your own little thing, and we don't have to pay attention to you. And he then goes on to mistakenly tell me where I'm coming from, which is there was a time when programming was totally dominated by math, but now they're just related, and programming is not math, and blah, blah, blah. And the example is bad because 1 + 1 has been understood by almost all programming languages. So entirely missing the point of the advantage that I was trying to make of symbols versus words. And how if you didn't know what the weird symbol for the numeral 1 was, or that weird plus thing was, you wouldn't understand 1 + 1. And he clearly missing my point, and I tried to put it back on track by pointing, no, it's not just about math, it's about using notation for programming concepts. But it's like, again and again, we kind of see the same mistaken ideas over and over, to the point where I'm really thinking I should just come up with an FAQ and pick 5 of these things that come up again and again, and try to deal with them once and for all. But I haven't gotten around to that yet. But it is very illuminating to see how people who don't have experience with programming are much more open to these ideas than people who do, because once you spend all that time and effort learning how to do things in C or Python, it's really painful to have to unlearn it all to do things in a completely different way. And I found that people are extremely resistant to it. So I think along with Morten's idea of getting them while they're young is probably a key to this whole thing. And getting in there first is probably also crucial.
Thank you. Certainly worked on me. It's yeah, completely spoiled. Completely.
Can I add a couple
spoiled.
things to that, Stephen?
Yeah, please.
Okay, it's certainly been our experience that some of the best programmers that we come across are actually not from computer software at all. They're from philosophy, they're from other branches of engineering, possibly. They're from mathematics, maybe, but their background is definitely not programming. And it's interesting too, the 1+1 example is really interesting because obviously mathematics introduced a set of symbols. There's symbology there that everyone's comfortable with. Depending on how advanced your level of math is, you would be more comfortable with some symbols, integrals, summation, and so forth. But everyone gets the plus sign, and everyone gets the division sign, although it's ambiguous because there's a second way to write it. And everyone gets exponentiation. But it's interesting that when you look at languages like C, they went out a bit out on a limb there by introducing certain symbols like and or, and double or. And they use things that other programming languages did again, like asterisk, asterisk, meaning raised to the power. And this introduces new symbols, new symbolism, a small barrier, let's say, for people to have to overcome, but nobody had a problem with it. I think there's a level below which it's not an issue. It's either known to everyone or the distance between what's known and what we're asking you to learn is so small that you can easily assimilate it. And I think that's the case with C, for example. No one complains about the symbology of C. But when you look at something like APL, that gap, that distance is much higher. But then, of course, so is the plane on which you can think, for all the reasons that Ken was so positive about this approach. It's so succinct, it's so evocative, it's so natural in many ways once you take the time to learn it. Like any language with symbols, it makes so much sense.
And so, no one complains about the lack of consistency and extensibility with C symbols. So you have, C++, C, C minus minus, minus minus C, and what's C star star? Well, that is, or star star C, that's unrelated to multiplication.
Right.
And no one bats an eye about the fact that you have this elaborate plus plus minus minus thing, and it only applies to those two things and doesn't go anywhere and doesn't apply anywhere else in the language.
And even that was a concession to the hardware as much as anything else.
I also have some thoughts on that.
Can I come to you on this? You've been famously working with a very dense piece of code written in symbols. The first time I met you, you were wearing a T-shirt with the source code for your Codefund's compiler. You're wearing it now. Yes, printed on the front. That was the entire source code of the compiler. I don't know how many of these you have. I know that you edit the source code. Perhaps you could say something about this here and also pick up a couple of 2 or 3 questions out of the Q&A that you flagged.
Yeah, so I've got a few questions that are all related to this, and the symbols are a good place to start because I really, I believe like we're all wrong in this, in a large sense. The APL and the symbols community tends to sort of get really defensive about their symbols, saying, oh, well, you guys aren't being rational, the symbols are this, and that's a good argument, right? Symbols, inherently, there's nothing wrong with symbols, and symbols have clear advantages, and nobody from a rational standpoint can say that symbols aren't objectively better from a historical, anthropological examination in terms of effectiveness and raising the human cognitive capacity and all of this stuff. Right, but that's really not the problem we're dealing with. And the argument that people make on the other side, complaining about the symbols, is also a bit of a straw man, because the programming community at large has consistently been shifting more towards symbols in their programming languages across the board. If you look at most of the modern programming languages that are getting a lot of attention from researchers or a lot of attention in a lot of spaces, many of them support or involve symbols in computation. And a few of them are actually very popular but don't do this, but most of the other ones tend towards using a lot of symbols. So from a rational standpoint, there's not really a good base or an argument there. But the problem, I think, that isn't being talked about is the why question. And this is always a human motivation problem. I don't think it's a problem of symbols themselves. It's a problem of justifying the symbols, and it's a problem of justifying a way of approaching programming that justifies the symbolic way we're working with this stuff. And that's something that I don't think enough people are talking about or doing enough research on or doing enough study on. And so like when we complain to people that, you know, you already know plus and minus and divide, and that these are inherently valuable symbols to have, well, we've got an education problem across the board on computing in terms of how we teach people to think about computing. And that's why I've talked a lot about sort of anti-patterns and patterns in APL programming versus other programming languages. And it's not so much the symbols that I think we need to focus on, but providing people a reason to want to do the symbols, right? So if you're in the Haskell community, there's often a reason to want to do those symbols for one reason or another. And it could be a social aspect, it could be a marketing thing or whatever. But I think we've done a bad job in the array programming community of providing suitable motivation to drive why we want to do this and why our programming is better. And you can't just claim that your programming is better. We have to actually have real answers to the complaints around the symbols, which is largely tersity and maintainability. And so really it's this presumption that tersity and concision leads to unmaintainable code. That's the fundamental fear that I think people have when they're working with that code. And we have to address that. And I think one of the problems is a lot of people are not addressing the software engineering concerns of the notation in a holistic way that actually tells a story of why this stuff works at scale. So it's very easy to look at the notation and say, oh, this is a toy, you know, or, oh, this works. Like, I can't tell you how many times the reason my compiler exists in the form that it is largely is because at each incremental stage of showing off these ideas of working in this domain, everybody said, oh, well, so it works for that one little area, but that's a special case. Oh, so it works again for this one little area, but that's a special case. And it's just a continuous stream of, oh, that's just a special exception. That's just a special exception. And so until you build this entire, well, in my case, a compiler saying, no, it's not a special exception. This whole principle works across the board, and I can demonstrate it across the board using the exact same principles, you don't, people don't believe you, right? And so there's this issue with believing that the notation is just sort of an exceptional thing in this small niche. And I think that's the problem that we're not addressing well enough, is that this is a general principle, not just a specific one. I think Morton's got a comment there.
Yeah, I'm just saying there's some really fundamental problems here, right? Because the people who really benefit from APL don't know computer science. So they wouldn't know how to begin to formulate the benefits that you're speaking of. Yeah. And at the same time, I don't think this is generally true, but I have spoken to programmers who told me that they became programmers because they didn't want to do math or chemistry or engineering. They didn't like that scientific stuff. They wanted to do programming because they thought that was somehow something they could deal with. So it's really two really different groups of people.
So it's actually three groups of people that we're struggling with. We're struggling with an over-specialization in three different areas. One is the computer scientists. One is the sort of the domain experts that use APL successfully to solve problems. And then there's the HCI group, right? Which the whole job of HCI people is to study this interaction between computational systems, how they're expressed, and how people interact with those things. But those HCID people are very, very poorly represented within the programming languages community. And so there's been very poor amounts of research on that, very, very few. At Functional Conf, I think in 2017, I talked a little bit about this in my anti-patterns talk. But I found two papers from the 80s, Miller 1981 and Galat 1985. And then from 2001, there was another paper from Payne on how non-programmers tend to write algorithmic descriptions of things and how they do things. And if you look at those papers, they're not conclusive by any means, right? They're very early elementary studies on this stuff, and there's a lot of potential gaps. But the things that they find are much more closely aligned with how APL and array languages approach problems than how a lot of these other systems are approaching those problems, or at least traditionally how they would approach those problems. But we don't have enough of that body of research to say, okay, here is why this stuff is done, right? And here's why it works. And we don't have enough people in these spaces basically crossing over their domains to do that kind of research. So there's this whole problem with HCI in programming languages, which is part of the whole symbols question at all, that isn't getting enough funding, that people aren't spending enough time doing it, and you know, that's just a whole big thing. And I've spoken about that at length before. But then there's another aspect of this, which is the maths problem, right? So you know, where Morton talks about programmers getting into the world to avoid doing math. Well, there's actually probably a very large proportion of people who have chosen their jobs precisely to avoid math, right? And there's a question of, is this a problem with math, or is this a problem with how we teach math? Or is this a problem with a disconnect between the way math is being taught and how it's actually used in the real world? And Stephen Wolfram from Mathematica has written a book recently called The Maths Fix. And his argument is essentially that we are totally teaching wrong the way, or we're teaching math the wrong way completely. Now, I don't know if I fully buy into all of his propositions here, but there's a really compelling concept that the tool of modern mathematics is the computer. And so if we're ignoring the computer as we teach math, maybe there's a problem there. And so a stronger connection between computing and math might be warranted. And if you go from the academic side, you've got homotopy type theory. And they're also arguing that you can reformulate mathematics fundamentally as computation through type systems and some of these other things. And these are sort of approaching the math and computing problem from different angles. But the closer that those come together, I think the more relevant a concept like APL and array notations becomes to a broader class of people, and it becomes less, oh, that's just a special case. So, you know, those are some preliminary thoughts. I don't want to just, I could obviously talk for a long time on that stuff. But I guess there were a few questions in here that we should probably answer. I guess
I'll interrupt you for just a moment, because we're dead on our close time. There's no reason why the meeting itself need not run on, but there's people who would be expecting it to finish at this point. So just at this point, I want to announce that the recording of this event and any slides that the presenters care to share will be going up on the British APL Association's website. You can find them easily online. In fact, it's britishaplassociation.org. And there will also be some kind of follow-up meetings. We've been most impressed by the response to this event. We had, I think, 180 or so people online at one point this evening. And we're going to invite some of you to identify as champions of the notation. And we will meet online to talk about things that we can do to promote and extend its usage. This isn't the end of that discussion. Thank you very much for joining us tonight. And I'm going to just throw this back to Aaron.
Yeah, sure. So I think Cabello, I hope I'm pronouncing that correct, asked how good and or plausible is the future where Iverson notation becomes a standard notation for mathematical research? And that, I think that's mostly answered by my previous comments, is that mathematical research, we have to get a closer connection between computation and math, and have that connection be more acceptable within the mathematical community, but also within the programming community at large, to where math is not a scary concept, but it's a practical concept now, because computer scientists, programmers, people in finance, they're doing math, right? They just don't want to call it math. And so the better we can address that, the more likely we can get something like computational notation recognized within mathematical research. One of those big areas, I guess, let's do the, Alex asks about NumPy and machine learning and where machine learning and APL and those spaces are. I know I saw a comment about some of the people doing some machine learning stuff in Q, but from the APL side, we did a very small pilot project to sort of experiment with what the notation was capable of achieving within an APL space, working on a small machine learning prototype. And our conclusion, basically working with somebody external, was that without any additional library support and just taking the notation itself, the raw, non-specialized APL notation was more ergonomic for doing machine learning programming than the specialized machine learning libraries that already existed, and was significantly shorter, more flexible. The source code was much simpler and more general at the same time, and could be adapted more easily than a lot of these specialized libraries.
And this is a point for Nick to plug his book, which he covers machine learning in about 300 pages using Q.
So I just, in response to that, I spent 5 years going through many different machine learning algorithms and just challenging myself to re-implement them in Q. And would a vectorized approach to these algorithms actually prove efficient or not? And would the notation using Q, a functional notation where you're not passing dictionaries around with optional parameters, but you can elide functions or make projections and things like that. How does that functional nature tend to a good environment of machine learning? And I found that the implementations, just as you said, were quite elegant, very short and concise, and revealed the essence of the algorithm to the user more than any triple nested for loops inside a Python or Python.
Except the performance sucked.
Triple nested for loops would be one exception where you might have to do it. So like recursive RNN, recursive neural networks might be something you would need to go about, or make it a native operator to do that for you. But yes.
Yeah, so one of the things that the Codefense compiler project is targeting is to provide that GPU high performance support on top of the machine learning algorithms expressed in an APL style. So we worked on some deep learning algorithms. What is it? We experimented with the UNet vision deep learning algorithm, and that's one of the things we're working with to try to get the compiler up to snuff where it can handle that kind of stuff. It's not there yet, but I'm working to target. That's one of the explicit targets inside the Codefense compiler, to make that more accessible, not only from an ergonomic standpoint, but from a performance standpoint.
I think there's also something else with the strict reading from right to left. You lose some flexibility, whereas in MATLAB, for example, you can it notices a matrix multiplication followed by a flip transpose of the matrix. It will optimize that out. But with in Q, for example, if you're trying to do flip matrix multiplication, it won't know how to optimize that because it's purely operating from right to left.
Yeah, and that's one of the things that a compiler can help to do, is optimize those things out. Yeah. There was a question about cryptography. I'd love to hear if any of the maybe older hats knows of Ken's interest directly in cryptography, but I know in terms of his notation, some of the biggest players that I see in terms of their interest in exploring APL as an implementation for modern solutions is around cryptography, cryptocurrencies, modern elliptic curve cryptography, big number algorithms, things like that. That I'm seeing a lot of interest in array notation within that space.
I think in 1955 there wasn't much of a cryptography scene, right? That was very, very early days for cryptography.
Yeah, I think that's probably, it was more ciphers and computationally recreating human ciphers versus mathematically.
Yeah,
driven.
and there are early APL books and articles about ciphers.
Yeah,
for sure.
Yeah. And also there's a question about APL, J, K, and its derivatives in academia. And this is a bit of a pet peeve of mine. Anyone else that's been recently related to or connected with academia can chime in here too, but APL is old. So from a research standpoint, it's not the new hotness in a lot of areas from a programming language standpoint. And one of the things that's always been difficult in certain areas of academia is proving how valuable not doing something is. And so a lot of areas in academia, particularly the computing world, thrives on novelty and thrives on just enough complexity added to an existing system to make things novel and interesting. And if you can demonstrate that you've achieved the same thing by getting rid of all this new cool tech that you've done and just use old school tech, that in theory would be a great idea, but in practice, a lot of people fail to recognize the value in that inherently from an academic research publication standpoint, because you're going to publish a paper saying, oh, we don't need anything of this. We don't need all this neat, cool stuff. All we need to do is take what we've already done and it works just fine. Well, it doesn't sit as happily with a lot of the academic crowd as it could. So with APL, one of its values is oftentimes that you don't need to do or use or leverage all of the things upon which the computing industry has built its large academic library. So if you're taking away all of that, there's almost a de-incentivization to explore APL in that space. And it's not that it hasn't been done. So there's, for instance, Alan Shivers and a number of other people that I think Dave Thomas was citing have done work on rank polymorphic type systems, which is really cool. And that's still early days research, I think. But there's a lot of interesting research that's going on around parallel computing, around some of this stuff, but it's not, very little of it is fundamentally based on APL. And I think maybe one of the areas where APL needs to become more present in academia is not as a center point of the research itself, but as a tool to drive research in other domains. And that will only happen when it becomes a large, marketably popular enough to overcome the institutional momentum in those academic communities, I think.
Aaron, thank you for that. We're coming up to 10 minutes over time. A quick hands up from anyone on the panel who'd like to share our last thoughts on this. No? Okay, I think we've had, Roger, please.
Just one thought. And my comment is, don't despair. You may want to look into the history of the exponentiation function in mathematics and see how many hundreds of years before it arrived at its present form. So
look at how long Hindu Arabic notation took to supplant Roman numerals.
I actually wanted to add something too. So Ken and Greg Wolfram's idea basically about introducing mathematics through from a fundamental programming perspective is, well, that's a principle that Ken had in the 70s or something when he wrote his book on an algebraic course based on APL. He taught mathematics that way. And the reason I mentioned it goes back to what Aaron was saying, because I think one of the things we've lost in the last 30 or 40 years is the pedagogical aspect of APL in universities and high schools. That was there in the 70s, in the 60s even, to a lesser extent in the 80s, was already waning by the 80s. But a number of us probably on this call, certainly myself, are involved in this community because of being exposed to it through academia in some way. The university I went to actually had APL time sharing systems from IP Sharp Associates, as a matter of fact. And it was a very valuable thing. Although I didn't learn APL at university, many people there knew of it because of that. And so I was able to talk about APL with professors there who didn't know it, and they were somewhat sympathetic. But I was never exposed to a course that taught it at university. I was, however, exposed in high school. Now I think either of those is extremely unlikely. And I think what would be really, really good is to find some way to get back to the point where people in academia who have influence and who are writing courses and giving them are interested in this topic and are willing to put it forward as a tool of thought, literally, as a notation, and possibly as a programming language for subsequent use as well. And I think if you do that, one of the ideas that we had in the 70s and 80s was if you can get people who are young and interested in APL, not only do you create a vibrant community, and that's great, but when these people become older and they're in decision-making positions, they're going to proselytize for APL just as had been done for them when they were younger. And so you end up creating this momentum that is really, really useful, and we don't really have that. So I think it would be great to somehow get back to the point where we get academics interested in APL. I completely agree, Aaron, with your comment about how what's old isn't necessarily shiny and new and everything, and academics want to write about new stuff. They want to build on new concepts. They want to show that they're au courant with research, and as a result, that works against us. But I just wanted to make the point. I think we've lost something, and it would be good to try to get back to it somehow.
Just to that point, machine learning was an old thing until it became a new thing again. So there's nothing to say that the ship has sailed for us. And I think fundamentally everything we've been kind of talking about today, like notation as a tool for thought. I mean, programming in and of itself is just a kind of a way of translating your thoughts to being able to be executed by a computer, right? So something like the asterisk as an exponentiation was helpful in C because people understand multiplication and they understand kind of that asterisk, like the two together could be a combination of multiplications. So potentially for APL, like in the same way that any kind of programming is going to be a sort of a proxy for thought, any sort of symbology is a proxy for representation. So I think as much as you can kind of encode within the symbology itself, the representation of the thought, the more you can benefit. So like the question about whether it should be a circle, I think very back at the very beginning in one of the talks, I can't remember whose it was, perhaps yours, Morten. You had all the slides with and I'm not that familiar with APL myself, but why is the circle sign and why are these things represented this way is I think perhaps part of the barrier, right? Because it is a new vocabulary, it's a new language that people have to learn, and going through that process is that sort of mapping process and getting that familiarity is sort of the barrier to entry. But once you've overcome it, and this is what I've discovered from talking to everybody who seems like who loves coding in Q or any of these languages, you really hit your stride then, because you've got a lower brain to computer interface, right? You can more easily take what you're thinking and make the computer do it, which is fundamentally what we're all trying to achieve with any sort of programming, really. So yeah, my sort of closing thoughts for the evening.
Thank you, Rebecca. That seems a good note to close on. There will be further meetings on how we can spread and promote the notation. Thank you again, panelists.
Actually,
Rebecca.
Sorry, I also wanted to say that Rob has his hand up. Rob Hutchinson in the attendees. And knowing Rob, I would sort of like to hear what he had to say. That's all.
Jake, can we hear from Rob?
I'm here. So look, congratulations. It was a very good panel, and thank you so much for organising, Stephen. Also, hello to the IPSA folk for here for so long. I still remember the three-letter acronyms: Morten, Huey, JKT, RBE on the call, etc. I was lucky to be RHO, so I was one of the primitives at IP Sharp. I wanted to reflect one thing about Ken that came up earlier, and I wanted to convey this, so it's a good time in the close. I was APL 88 program chair, and we arranged for Ken to fly to APL 88 in Sydney from Toronto, along with the three Jeans: Jean Iverson, his wife; Eugene McDonnell, his good friend; and Eugene's wife, Jean McDonnell. It was always a joke that Ken brought three Jeans to Australia. Ken walked into the arrivals hall where I met him. He was wide awake, animated, and very sharp. Not like me when I fly to Toronto or New York. I'm very tired. While driving to the hotel, Ken excitedly wanted to share that he and Eugene swapped seats with their wives and spent a large part of the trip developing the concept of verb trains. 3 was simple. Effectively, it was just function composition FG of H in algebra, and later called a fork, but he wasn't sure what to do with 2, which he later called a hook, but he thought he might just add a null function to make it a fork also. And as we drove over the Sydney Harbour Bridge, I recalled Jean saying, Ken, look at the Opera House. And Ken replied, oh yeah, well, I'm just talking to Rob, and we'll see it on the way back, right, Rob? He always had more interesting things to do. Engaging with Ken was always put you on your guard. He would often open the floor to you when you expressed a view to ask, why do you think that? And then he'd listen and ask careful probing questions. The result was verbal sparring, and he would make you seriously reflect on what you were saying, then often catch you out with simple questions. He would let you see your own shortcomings, and I considered such conversations were like verbal chess that usually concluded with the verbal equivalent of checkmate or to lay down your king and surrender. Ken's the only person I can recall who attentively attentively shared such challenging conversations. And I remember this is a pleasure to experience that. And finally, to Stephen, good to see you again. Very much looking like a younger Patrick Stewart. Hope to see you on the USS Enterprise one day, Stephen.
Rob, thank you. It's good to hear from you.
Rob, actually, Ken bought 4 genes in Australia because he himself is Kenneth Eugene Iverson.
Good point, Roger.
Stephen,
good to see you all. Thank you.
Well, thank you all for attending.
I think Joey wants to say something too, doesn't he?
Yeah, he's got his hand
up.
I put my hand up, but it's age. I've forgotten what it was I wanted to ask. But I really appreciate this, and it was great to see all you and hear all the comments. And I look forward to reviewing the comments and things when they're put up on the British APL website. Thank you very much.
Good to see you, Joey.
Well, thank you, everybody. And we'll call that a wrap for tonight.